Welcome to FMSP Online Revision. This session is for AQA M1. Topic is static and forces, and we're looking at question 4 from January 2011. So this question is all about a canoe which is paddled across a river with width 20 metres. The canoe moves from the point X on one bank of the river to the point Y on the other bank, so that its path is a straight line at an angle alpha to the bank. So we've got this on our diagram. The velocity of the canoe relative to the water is 4 metres per second. Again, that's marked in, and that's perpendicular to the banks, and then the water flows at 2 metres per second parallel to the banks. And it tells us to model the canoe as a particle. So 3 things to do. First of all, we want to find the magnitude of the resultant velocity of the canoe. Secondly, to find the angle alpha. And thirdly, to find the time that it takes for the canoe to travel from X to Y. So let's just have a look at that and put some information on a diagram down here. So this is the 4 metres per second, which is the velocity of the canoe going across. This is 2 metres per second, so that's the water flow. And then those, if we add them nose to tail, so we have a triangle of forces, then we will find the resultant velocity. The magnitude initially is what we're being asked to find, and then in part B we'll be able to find the angle alpha. So in part A, it's just Pythagoras' theorem tells us that v squared is 4 squared plus 2 squared, which is 20. So v is the square root of 20, which we can write either as 2 root 5 or in decimals 4.47 metres per second. And then we're asked also, as I say, to find this angle alpha. So that angle alpha corresponds to that angle alpha. Well, it's alternate angles. So we can use alternate angles there. And so the tan of alpha will be the opposite over the adjacent 4 over 2, which is 2, which means that the angle alpha is tan to the minus 1 of 2. So alpha is 63.4 degrees to 3 significant figures. And then in the last part, we're asked to find in part C the time that it takes for the canoe to travel from X to Y. So time is equal to distance over speed. And so the easiest way to do that is just to take the perpendicular distance divided by the perpendicular speed, 20 over 4, which is 5 seconds. So there were, 6 marks for that question in total, 2 marks for each part. So in each of those parts there was a method mark and an accuracy mark. So a method mark for Pythagoras' theorem, and the accuracy mark here didn't matter which form you gave your answer in. And again, a method mark for using trigonometry, and the easiest thing there was to use tan, but you could have used sines and cosines because we had the hypotenuse, and an accuracy mark for the angle. And then time is distance over speed is a method mark, and then an accuracy mark for 5 seconds. So 6 marks in total. So don't forget, if you want to watch other revision videos, then you can do that by going to the Further Maths Support Programme website and following the link to online revision.